Hi everyone. In this video, I plan on describing what Perlin noise is, why we use it, and how we use Perlin noise to generate noisy bathymetry files, and what a bathymetry file even is. So to begin with, Perlin noise, and 2D Perlin noise in this situation, is a very soft, very easy to look at kind of noise. It's often used in CGI effects. For instance, when you're generating fog, you'd use Perlin noise. The reason it was designed is it mitigates the very computerized effect of CGI. It makes things look more realistic. And as you can see by this picture, this is very soft. You have a little bit of black, a little bit of bright white, but besides that, it's mainly gray, and there are no significant transitions. So we use that to generate noisy bathymetry files. How we do that specifically is in the GitHub, in the bathymetry file, under the folder AGC26, under the folder AT, which stands for Acoustic Toolbox, there's a file called Perlin2D.m. Now this was created by a guy named Steven Cholowiak, and the URL to find his work is right here. I slightly modified it to fit our purposes better. And kind of how it goes is, you generate your little array, the size of it. Then you generate noise with this function and this, and finally this is this one line is really what I modified with it, so I centered around 0.5, so it's between 0 and 1. And this, this is how you create Perlin noise. So with the file, or rather with the script generate_noisy_btys.m, we can then apply this Perlin noise to an inputted bathymetry file. So this function, noisy btys equals this, takes in your Perlin noise s, your inputted bathymetry file, bathy file, nm, and bathy file edit. Nm is the array size of your bathymetry file, and bathy file edit is the name of your bathymetry file. As this is used in a function, you can generate as many noisy bathymetry files as you want. However, you need them to be individually named. So I keep saying this word, bathymetry file. What on earth is a bathymetry file? Let me pull up an example. Weymouth3D.bty, which is also in the same location, and some associated document with it. So Acoustic Toolbox is really nice in that it has all of these document files right here under doc. If I pull up the ATI_BTY_file.htm, I can get this HTML of what is a bathymetry file according to Acoustic Toolbox, how can we use it. So this documentation file is great. It's great reference points for future bathymetry makers. So the Weymouth3D.bty file starts with the first line, apostrophe R apostrophe. That stands for range, because we're looking for the range with the third and fifth line. So these lines represent the range of our bathymetry file. This line right here and this line right here show us the columns and the number of rows for our bathymetry depth files. And from here on out, this is our depth. Lines 6 through 101 are our depth files. We can scroll through. If we actually visualize the bathymetry file, this is what we see. And subsequently, these are the numbers that we want to apply the Perlin noise to. Because as we apply noise to these, then suddenly the bathymetry file, if we were to view it, starts to get kind of bumpy and starts to get a little noisy, if you will. So the way we do that is under the file generate_noisy_btys.m. This is the function where we apply Perlin noise to the bathymetry file. So the way this works is it opens the input of bathymetry file, the standard, what we're trying to make noisy. It removes the header. It then takes in the number of columns, number of rows, and applies Perlin noise right here to these values. Closes that, opens up the new bathyfile_edit bathymetry file, which is just the name of this specific iteration of the bathymetry file. And again, as this Perlin noise is randomly generated, RN, NDN, every bathymetry file is going to be different from the other one. We then write that onto the bathymetry file, print it, save it, and suddenly we have a noisy bathymetry file. And that's how we generate that. This is used for training data. In future videos, I will describe how it's used, how we generate sound files, how we generate pings from that, and how we actually train the neural network. This has been fun. Please like and subscribe to the video. I'm a sucker for that kind of validation, and I hope you look at the future videos.